This meeting is being recorded, just want to let everybody know. And another thing, if you're on speaker mode and you don't happen to be muted, if you sneeze, everybody's going to say God bless you because you're going to be on a screen. So whoever makes the noise goes on the screen. So that's why I suggest you put yourself in mute mode. Well, I want to welcome, first of all, everyone to the November meeting. I want to start off by just thanking Allison Simpson and the Florida National Guard for the tour that they gave us this past Friday. She toured the St. Francis Barracks, which was originally a monastery turned into a military installation in 1763 and has remained such since, and the National Cemetery. We had a great turnout. The weather was good. We thought we were going to have some problems with the weather, but everything worked out well. And at the end of the tour, we did have a little toast. For the people who don't realize it, the St. Augustine Archaeological Association is 35 years old. We did a little recap on the history. For the people who weren't at the tour, let me just reiterate what was said. First of all, back in 1984, St. Augustine did not have an archaeology ordinance. It didn't have an archaeologist, and it obviously didn't have a SAAA organization. And in 1984, there was some work that they were doing on St. George Street, running some utility lines. And when they were digging, they found under the ground was just a ton of artifacts and related to the history of St. Augustine. And it was decided at that point that there ought to be an archaeologist, there ought to be an archaeology ordinance, and a bunch of people just got together and said, you know, we really ought to have an association. And they talked about the association in 85, is actually founded in 86. But they sat down and they said, you know, we ought to have an organization that anyone interested in archaeology in St. Augustine could join. And believe it or not, the dues were $3 a year for an individual and $5 for a family. They said that organization should run monthly meetings every other month, not monthly, but every other month, and get someone to lecture on archaeology. They also said that we probably ought to have a newsletter that we put out periodically. They also said that there should be some tours to local points of interest in the field of archaeology. And if anyone was interested in picking up a shovel or a trowel, there would be an opportunity to do that. And that was 35 years ago. So we then looked forward to this year, 35 years later, and we saw that a lot of things have changed, but a lot of things have not changed. We do have the organization. The dues are now a whopping $15 and $20 a year, so they went up. We do have a newsletter we put out. We don't mail it out anymore, but we email it out. We obviously continue to have meetings, of which we are on right now. We have them actually every month except for the summertime. We do run tours similar to the one that was run on last Friday. And there's quite a bit of quite a few of us that do volunteer with the city, both in the field and working in the lab. So things have really not changed in 35 years. And at the conclusion of the toast, we had a cake, and fortunately there were 4 people who were original members and founders of the association who had the opportunity to cut the cake. So it was a good time, everyone enjoyed themselves. But in order to have an organization continuing like that, you need a board. And I just want to talk a little bit about the board because nominations are coming up. The nominations will be in the January meeting. We normally announce who's running during the November meeting. So I just want to, first of all, go through roughly the positions real quick. The board actually is made up of 10 people. There's 5 board members and 5 officers. The board members have a term of 3 years, not renewable, but they could be they could be back-to-back terms. They could be put back on the board after they leave it for a period of time. And the officers are in the 1-year term, so they're elected every year. With the exception of the president and vice president, there is a term limit of 2 years. So with that in mind, we did have a nominating committee made up of Janet Jordan, Pat B, and Janet Fittipaldi. And they came up with a slate of officers, and I'm just going to mention them. Their bios will be in the newsletter, as well as the way that you could name additional people and name someone actually in January if there's other people who are interested. But there are 2 board positions being vacated. Courtney Crum, who is currently the corresponding secretary, one of the officers, has elected to fill one of those 3-year board positions. So she'll be moving off the corresponding secretary position and taking up a board position. And the second was David, and I always mispronounce his name, David K. David, how do you pronounce your name? He's on, I know. Well, I don't want to mispronounce it, but I don't even want to attempt it. But
all right, it's Casriel or Casriel. I'm sorry.
Casriel. Okay, David.
I'm over the dinner table. Sorry, I'm toasting you with some wine. So and SAAA.
Super. Okay, well, David was on the board for a short stint. He filled in for somebody who moved off the board. He didn't have a full 3 years, so he is actually being considered for the second slot. The other positions, the president, vice president, secretary, and treasurer, the original people are on the slate. So if anybody has any additional people, look at the newsletter. You'll be able to nominate more people, and at the January meeting, we will make the elections. Want to move a little forward to December. We will have a Christmas party. It will be on the 14th of December, and it will be at the Lambia House. We'll start at 5:30. We'll get a formal announcement up. SAAA will supply the main meal, a turkey, ham, all the beverages. And all we ask is that anyone coming, any member coming, because it is a member-only event, to bring either an appetizer, a side dish, or a dessert. If you're not a member, feel free. You can come up and sign up, and we'll make you a member on the site. But as you know, as we always say, the SAAA meeting is the best Christmas party in St. Augustine. Want to talk a little bit about a conference that's coming up. There's an organization we refer to as FAS. It's the statewide organization of which we're a chapter. Some of you people might have attended the conference in St. Augustine in 2013 that we ran. Well, we're being asked to run it again in 2022. 23, excuse me. And we need a lot of help. Some of the things we're looking to do, we need help. We're going to be running tours. We're going to have a welcome center, a formal banquet. We'll have to set up the facilities for their presentation, arrange for hotels, greeters. There's a whole lot of things that we want to get rolling here, and we want to show the rest of Florida. We want St. Augustine to shine and show them how to do a conference. And like I said, we need help. Some folks have approached me at the tour, and what I'm going to do is I'm going to later on in the chat box put my email. If anyone's interested, just send me an email. We'll get back to you. And again, we need all the help we can get. And with that, let me end that and see if Robbie's on with any information from FPAN.
Hey, Don. Yeah, I just have a couple things. I'll be real fast. So say there was a cleanup at the Pinehurst Cemetery, which is a historical African-American cemetery in West St. Augustine. And that happened a couple weeks ago. So that's, if any of you all helped us several years ago, we did a cemetery headstone recording project in San Sebastian. And this is the cemetery, it's kind of right behind it. But it was always so overgrown, we could never get in there. But now it's been cleaned out sufficiently that we can get in there and start doing some headstone recording. So I'm going to be probably starting that up on a weekly basis for a little while. So if anybody's interested, I'm going to put my email in the chat and just send me an email. Just know that, you know, I'm not trying to set anybody off from it, but just so they know that there could be snakes and there are no bathrooms. So it might not be a project for everybody. But if that sounds like your kind of thing, just send me an email. And then we do also have a lecture coming up later this month that's going to be called The History of the Florida East Coast Hurricanes. So that's going to be coming up via Zoom on November 18th. And you can also just email me if you're interested in that, and I'll send you the link. It's free, but just we need to send you the Zoom link. So that's it.
Okay, thank you. That is a pretty neat cemetery. I did go out there with Bobby, I guess it was about 1.5 years, 2 years ago, cleaning some tombstones, and it was a very interesting place to go. I don't think Catherine is on from St. Augustine Archaeology. I didn't see her on. Catherine, are you on? She said she probably couldn't make it, but she did give me an announcement. Catherine is part of an organization in St. Augustine that working for the city called the City Historical Preservation Organization. And unfortunately, Jenny Wolf, who was running that, recently left her position. Her assistant, Julie Courtney, took over that position for Jenny. And that leaves a position available in the city. So if anyone is looking to get involved with the history preservation, archaeology, if you go on the St. Augustine website, which is citystorg.com, all the vacancies are there, and it is called the Historic Preservation Planner is the position, and she wanted me to make that known if you or anyone would be interested. She also sent me the artifact of the month, which I will put on the screen for a moment. We'll take a look at that. And at the end of the lecture, we'll see if anyone knows what that artifact is. I think Susan, you guessed it twice, didn't you? I think she did. Okay. One last thing before we introduce our speaker. I know Nick has been working on the education fund. We have made some selections and some presentations, and that will probably be in the upcoming newsletter, and we will talk about it at our next meeting. But there were any number of great candidates who submitted applications for that scholarship fund, and a number of them were selected. And we're proud of the selections, and I'm sure they're going to do a great job. Okay, with that in mind, let me introduce our speaker. It's John Endonino. He's an associate professor in archaeology at Eastern Connecticut University. And his primary interests are the social conditions and lifestyles associated with mortuary monuments found in the St. John Valley and Atlantic coast in North Florida. He's also done extensive research on stone tools and their sources and how they're used in production. So let me turn this over to John. He can introduce his presentation, and we'll go from there. John, take it over.
All right, thanks a lot, Don. Let's see, shared screen. There we go. Everybody can see that okay?
Good to go.
All right, fantastic. Let me move some things around here on my screen so I can actually see what I'm doing. That's a little bit better. Okay. So, hello, I'm John Endonino. Some of you know me. I've worked with a couple of you who are out there in computer land. So, Tomoka. How do I want to say this? I became fascinated with Tomoka about 3 years before I even finished my dissertation. And I had to work really hard while I was nearing completion of my doctoral degree at the University of Florida to not get sidetracked. And that happened almost happened twice. The first time was with Tomoka. The second time was with Coontie Island. I became interested in the banner stones and ground stone beads that were at Coontie Island because they're very similar to the materials that I had at the Thornhill Lake site over on the St. Johns River where I did my dissertation. So nearly got sidetracked. And as it turns out, in the last 13 intervening years, I've done a lot of work at Tomoka, which I'm going to tell you about tonight, but also have begun to do some work with Coontie Island, just south of St. Augustine there. Very fortuitously, I received an email from the current owner of the collection of artifacts from Coontie Island, interested in knowing more about them. And one thing has led to another, and there's a very good chance, looking extra good, that I'm going to Montana this summer to study them, because there's over 100 Noonan and Marion points there made from Florida materials, and I aim to analyze all of them. So my work in Northeast Florida is ongoing, it's long-term, and has taken some unexpected directions. One of the unexpected directions is looking at issues related to environment. Now, not to get too deep into the theoretical debates within archaeology, but the work that I did at the University of Florida was very much socially oriented, ritual, symbolism, and not so much interested in things like the environment. Now, after completing my dissertation work, getting hired at Eastern Kentucky University, I began thinking again about the next step. I'm still interested in archaic mounds, so what can I do to learn more about them? And so Tomoka was a natural outgrowth of my dissertation research, looking at late archaic mortuary mounds, ritual, symbolism, and things like that. So in 2013, I started the Tomoka Archaeology Project, or TAP, not to be confused with TAPS, the ghost hunter type folks, but the Tomoka Archaeology Project. And the first stage of research, not advancing for me. Oh, there we go. Okay, so Tomoka, where is Tomoka? Hopefully you've heard of it, maybe you haven't, but if you head down to Ormond Beach, just before you cross the bridge over the Halifax River on State Road 40, off to your left and up the road, if you're coming from the west, is Tomoka State Park. And the Tomoka Mountain Midden Complex is located within Tomoka State Park, nestled back in the woods. It's a big site. It's approximately 1.5 kilometers long, 1,500 meters, which is ballpark about 4,500 feet. So we're closing in on a mile in length, but it's not very wide, very narrow. It follows the shoreline, but the late archaic mortuary mounds and midden deposits are confined to approximately 1 kilometer. It's about 850, 900 meters from north to south, following Strickland Creek, which is a relatively recent hydrological feature, having been dredged in the 1950s. Prior to that, it would have been the edge of a marsh, and the site was situated on a Pleistocene sand dune overlooking that marsh with a pretty clear vista to the Tomoka River. So we're situated in northeastern Volusia County, near where the Tomoka River empties into the Halifax at Tomoka Basin. All right, so Tomoka is an an interesting place. When I started work there, we didn't know how many mounds there were, anywhere from 7 to 9, depending on who you asked. Artifacts from the site disappeared until relatively recently when they reappeared again. As it turns out, they were at the American Museum of Natural History, but they were attributed to the wrong site. And so when people ask for Tomoka, do you have Tomoka? It's like, no, but we have this other site on a creek that has banner stones. And so they began looking into it. And so we've located approximately half of the banner stones from Tomoka Mound 6. Where the other half go, we don't know. But the site has today 12 mounds. I'll give you the story about how that went from 7 to 12 as we go along. But most of the mounds are arranged along a Pleistocene dune ridge bordering what is today Strickland Creek, formerly overlooking a marsh leading to the Tomoka River. Now, most of the work that had been done at Tomoka was, the most extensive excavations were in the 19th century. A.E. Douglas dug into mounds 6, 5, and 2, found nothing in 2 and 5, but found 2 caches of banner stones and a pendant on the surface in mound 6. He called them ceremonial axes. They're not axes. We know today that they're banner stones, often interpreted as at-lattice weights, weights for spear throwers, and stylistically, they are Southern ovate and Wisconsin winged banner stones, probably manufactured in the Savannah River Valley of Georgia and South Carolina, probably made by the Mill Branch culture, which are a pre-ceramic middle to late archaic group who were known for their soapstone and other hard stone crafting of banner stones. All right, so the Tomoka Archaeology Project began in earnest in 2013. I got a small grant, brought some students down for a couple of weeks, and we put in test excavation units in most of the mounds at the site. Now, our purpose wasn't to dig up burials, and we utilized the methodology that I used during my dissertation research at Thornhill Lake to avoid burials as much as possible while still getting that stratigraphic and most importantly for this phase of the project, organic samples for radiocarbon dates. I wanted charcoal and nutshell, and I had absolutely no interest in human remains and did my darndest to avoid them, did a pretty good job of that. So in 2013, we started phase 1 of the research project. Simple goals. How many mounds are there? And how old are they? So initially, to determine how many mounds there were, I began mapping the site using traditional land-based surveying. And upon learning of the existence of LiDAR data from NOAA and FEMA, I promptly abandoned land-based surveying because that would have been an incredible investment of time and resources. And I might still be mapping. Remember, the site is over a kilometer long. That's a lot of terrain to map. So I let technology help map the terrain. We tested all 5 of the mounds we tested all of the mounds and determined several things. Number 1, 10 mounds. We went from anywhere between 7 to 9. We confirmed all of them. Mound 3 turns out to be a looter pit. It is not, in fact, a mound that has been potholed. It was just midden deposits that have been heaped up. And we didn't learn that until stage 2 of the research. But here's a weird bit. Just to the north and east of mound 4 is another mound that nobody mentioned. And people have been walking over the site for a while, but yet this other mound, unnamed, went unrecognized. So we took mound 3, decommissioned it, and moved it over next to mound 4. I'll show you a map here in a minute. What we learned based on the first round of research is that the majority of shell deposition, depositing of coquina clams or donax shell, and other shells as well during the Thornhill Lake phase period occurred between about 4,900 and 4,256 cal BP, or calibrated years. Just as a note, radiocarbon ages when they are received from a laboratory are radiocarbon years before presence. That has to do with the half-life of carbon, not human beings and their lived experience on Earth. So we calibrate radiocarbon dates to put them into something calendrical and more meaningful for human experience. So the late Mount Taylor, Thornhill Lake phase deposits established. We know how old it is, approximately. For those of you who are savvy in the prehistory of Florida, you might notice that the end of that date range overlaps with the Orange period quite a bit. Yes, that's problematic, and I'm going to revisit that at the end of the talk. But there's also a St. John's component. Prior to my work and the work of colleagues out there, the Tomoka complex was thought to be entirely pre-ceramic based on the work of Bruce Piatek. And we finally found some pottery out there. And it's stratigraphically isolated. It's restricted to deposits containing oysters and hard clam or quahog. So we found a St. John's 1 deposit out there dating between 3,300 and 1,200 cal BP. We have 2 radiocarbon dates to support that. 4 of the mounds were confirmed, but 6 of the mounds are mortuary in function. They have either reported burials based on previous research, or we accidentally encountered human remains in them. One of which is Mound 9, and upon identifying human remains, we stopped the work, contacted the human remains coordinator at DHR, coordinated with indigenous communities in Florida, came up with a course of action, which essentially was stop digging, cover it up, move on, which we did. But we did have a single hard clam that we were able to radiocarbon date from that context and give us data of about 3,300 years ago. So that's a St. John's 1 period burial mound. But 4 of the mounds, 2 are St. John's, 1 early, 1 late, and 4 of the mounds are Thornhill Lake phase dating between 4963 and 4447 cal BP at the 2 sigma range. But do a little bit of, you bring in diagnostic artifacts with known temporal ranges, you do a little statistical manipulation of the radiocarbon dates, and probably the mounds were built and used between 4850 and 4700 cal BP, which is at the end of the pre-ceramic late Archaic. So that's where we were based on our stage 1 research. We identified 10 mounds and we established a fairly reliable outline of the chronology of the site. That's all well and good. Now comes stage 2. Before we get to stage 2, let me tell you about this map. One of the things that we found during the first stage of research is that there were 10 mounds. There's from top to bottom, mound 1, which is located at the apex of a shell ring. We didn't know we had a late Archaic shell ring until we got the LiDAR data and began looking at the site. Now, if you are savvy in the ways of Archaic shell rings, this is not the sexiest, most impressive shell ring you will find. However, it is a C or U-shaped shell ring, open to the south, not very high in elevation, but I would like to highlight the fact that the LiDAR data that we have available from NOAA and FEMA is not the highest resolution. I think we've got about a 20 centimeter accuracy. That's about the best we can do. So there's about 8 inches of variance. So we do lose some of the finer details in terms of the shell ring and other things like looter pits on the top of the mound. Those don't show up with our LiDAR data because it's just not fine-grained enough. In any case, so you've got mound 1, mound 2, the newly discovered mound 3, which formerly was over here in a looter pit, mound 4, mound 5, mound 6, mound 7, mound 8, mound 9, and mound 10. Now, just a quickie preview of what I'm going to show you later. Mound 11 is right around here between mounds 8 and 9, and mound 12 is up here. This is a giant shell mound up here at the marsh bordering the Tomoka River. Now we come to stage 2. So we've identified how many mounds there are, different site features like shell ridges, and then the rough estimate of about how old the mounds are and the construction sequences that occurred. So stage one, simple project. How many mounds? How old are they? That lays the groundwork for the other work that we've been doing with stage two, which is to investigate the paleo-environmental conditions associated with site occupation and mound building. Now, I don't mean to suggest that the environment drove social behaviors like mound building, mortuary ritual. However, it's a variable, and we need to understand and control for that variable and see what influences it may or may not have had. There is some anthropological and thinking and some archaeological investigations where, in terms of environmental change and or instability, ritual and religion were used as mediating factors, to help humans make sense of and perhaps exert control over their natural environment. So interceding on behalf of the living through the use of the dead to address environmental and other issues related to environmental change. So it's a factor. I'm not saying that it's a causal relationship, but about 4,700 years ago, they stopped building archaic mortuary mounds. They stopped building sand mounds at Tomoka. And the reasons for that are unclear. But I'll get into some of that as we get further into the talk. Now, one of the things that really set me off on this environmental data quest was the fact that in my first visit to Tomoka in December 2017, there were a lot of freshwater snails and mussel shells in exposed areas of sand on the mounds. And currently, the Tomoka site is situated near brackish water, which has a high salinity. Freshwater snails and mollusks don't do well in environments with high salinity. So that led me to ask, where did these snails come from? And there weren't just a couple, there were a lot. And so that led me to form a couple of hypotheses. One, perhaps the Tomoka River and Basin were entirely freshwater ecosystems when the site was initially inhabited and occupied during the period when mound constructing was occurring, or alternatively, prior to the dredging of the intracoastal waterway, there were freshwater marshes and pond habitats behind the barrier island dunes, which we have historic descriptions for, that could have supported snail colonies and freshwater mussel colonies. So some of the things that I had in mind were, why are these snails here? What changed, and why are they currently locally extinct? They've been extirpated for approximately 4,200 years. What led up to this, and can we use those environmental disturbances to investigate why and how things at Tomoka changed? So I'll talk about the implications of these changes as we go forward towards the end. But first, what kinds of data are we talking about, and where did it come from? So in the second stage of research, we used data from the first stage and newly collected data that I'll show here in a minute to strategically place our excavation units and the kinds of samples that we were collecting based on characterization of the different sediments in a given area. And so you can see we placed additional excavation units here at the shell ring, one in between mounds 2 and 4. Another one here on a shell ridge adjacent to mound 5. This one was really interesting. I'm going to talk a lot about that one. Another unit over here adjacent to the pond surrounding mound 6. Test unit 11 on a artificially constructed ridge, and then units 16 and 17 down here on the southern ridge. Unit 16 was a really interesting. It was a relatively early deposit, Thornhill Lake phase in age, completely lacking shell, but had an incredible density of vertebrate bone. It's a weird spot. And then unit 17 down here on the South Ridge provided some really important environmental data. In fact, units 14 and 17 provided some really good data in regards to the environmental conditions, but I'll come back to those. Now here are all the mounds depicted, as well as the shell ridges. There are 12 mounds, a number of shell ridges, and the shell ring up here at the north end of the site. So based on our work during the phase 2 of the Tomoka archaeology project, we identified 2 new mounds, mounds 11 and 12, and investigated a number of other deposits, including shell ridges with units 10, 11, and 17. Okay, collecting the environmental data. The environmental data that we were seeking came from a number of sources, and in many cases, they were proxy data. So for investigating the terrestrial plant habitats and both the terrestrial and aquatic environments of the period of main site occupation, we used archaeobotanical and zooarchaeological data. Those were very helpful for inferring plant and animal communities around the site. Other environmental data are direct data. My colleague Sean Norman here, out in the marsh, driving sediment cores into the marsh in order to investigate changes in sedimentation that might show differences in the transition between freshwater marsh to saltwater marsh over time, and provide radiocarbon dates and perhaps even other mollusks in those aquatic environments. So we collected data from the marsh. We collected data during excavation through the collection of zooarchaeological and archaeobotanical remains. But before we did any of that, we did a geoarchaeological survey of the site core. And the way that we did that was through oak field probes and the characterization and description of sediments within the site core. And based on that, we were able to plot things like the density of shell, the kinds of shell produced, and whether or not organically enriched sediments likely to have preserved plant and animal remains occurred. And as a result of that work, we were able to demonstrate that there are essentially 4 areas of heavy shell concentration at the site, separated by less dense areas. And we were also able to show that once you get about 70 or so meters back from the edge of the current Strickland Creek and start heading into the pine uplands, the site disappears. It's anywhere at its narrowest 20 meters, at its widest about 70 meters, maybe 80. Future work during stage 3 will expand further to the north and the south and characterize those deposits. But for placing our test units, we used this coring data to investigate areas that likely had the potential to produce the kind of data that we wanted. All right, so I mentioned the sediment characterization. The zooarchaeological analysis was pretty straightforward. My colleague, the late Arlene Fradkin at Florida Atlantic University, worked with us on this project. One of my former students and one of her students, Stephen England, did a study of the freshwater mollusks for his master's thesis, which he is finishing up, I believe. But we processed our samples in the field. We had our own, I guess you call it water screening station, where we washed, dried, labeled, rebagged the zooarchaeological column samples and had those sent down to Florida Atlantic University. I'll give you a preview of the results of that. I haven't published on it yet. It is in the technical report, but essentially, subsistence practices didn't really change from the first inhabitation of the site through the very end. Now, granted that there are limitations to those interpretations because they're very small sample areas. If we sampled more widely across the site and more broadly, bigger samples, then we might have different results. But based on the data that we have, it should be no surprise to anybody who studied a lot of coastal sites. Fish that travel in dense schools and can be caught with nets were the main marine resource being collected. Herrings, especially menhaden, and mullet were the primary fish species. Donax variabilis, the coquina clam, was the primary mollusk. There are other things. There's deer, there's possum, there's turtles. Freshwater fishes are present, but are never the majority of the species represented in the assemblage. So the picture that we have based on the limited zooarchaeological data that's been analyzed to date, by the way, I have a lot of column samples. If anybody wants to write a dissertation, I have more than enough data for somebody to write a dissertation and a few master's theses. So if you know anyone, have them get in touch with me. I'm more than happy to share my data. But what you see is a record of subsistence stability through time, going from Mount Taylor into the St. John's 1 period. Some of the interesting things later on, though, is that around 4200 BP, at the, well after what we would consider the Thornhill Lake phase has ended, you do see people doing Thornhill Lake phase like things at Tomoka. But some of the notable differences are an increase in rays and skates. We know that based on their dental plates, and crab claws. We see a lot of crab claws later on in the deposits at Tomoka. Usually those dating between 4,400 and 42 cal BP. So zooarchaeology gave us some proxy data for what the environment was like. There are freshwater fishes present in the assemblage, probably coming from the Tomoka River, possibly also from those back dune ponds and wetlands that existed. But for the most part, marine resources are providing the bulk of the fauna that are being consumed at the site. I mentioned my former student, Stephen, who is writing his master's thesis on the freshwater mollusks at the site, and we learned a lot from those. I mentioned earlier, freshwater mollusks have no tolerance for saline environmental conditions. And so if there are colonies of freshwater mollusks inhabiting the Tomoka Basin, they would have been some of the first animals to go extinct because they cannot stand fresh water. So an analysis of those snails from mounds 1 and 4, which span the entire Thornhill Lake phase occupation at the site from about 4,800 plus cal BP, 4,900 cal BP up to about 4,200 cal BP. You see a decrease in both the frequency or the abundance and the size of the snails. They get smaller through time. That can be both an indicator of environmental stress, but also predation, in part perhaps by humans, but Vivipara, the banded mystery snail, has natural predators. Perhaps you've heard of shellcrackers. Shellcrackers eat snails, which, by the way, was one of the main species of freshwater fishes we had at the site. So we've got freshwater snail predators occurring in the deposits, and we've also got the freshwater snails. So we've got them, the snails, at the site. Column samples were analyzed. They're present from the beginning of site occupation up until about 4,200 cal BP. What does that mean? What it means, what we can infer from that is by 4,200 cal BP, give or take, the conditions in the Tomoka Basin were sufficiently saline for the extirpation, the local extinction of freshwater mollusks. What does that imply? Sea level rise. So the environmental data from our freshwater snails is pointing suggestively towards sea levels encroaching into the Tomoka Basin such that by 4,200 cal BP, it was sufficiently saline to drive freshwater snails to extinction. Now, that should have happened a lot earlier. Turns out, during this period, the late Thornhill Lake phase, the late Archaic, there were freshwater inputs through climatic patterns that would have been sufficient to produce outflow that could have kept sea level rise at bay for a while. And there's been some research done in the St. Mary's River basin in North Florida that shows a similar pattern. And the environmental scientists, I think they're working in Maryland and Virginia from universities there, showed that freshwater inputs from climatic patterns, rain, precipitation, was able to maintain a sufficient outflow to keep salt water from intruding into those smaller river basins. So we have some evidence to suggest that Tomoka may have gone saline a lot later than we thought. And we've got the snails to think for that. So the mollusks give us some pretty good environmental data. Now, test unit 10, which was placed on the ridge northwest of Mound 5, was done specifically because we found a bunch of snails, freshwater snails, in the road. So the road cut through the site, goes over this shell ridge. There's a bunch of mollusks, freshwater mollusks there. Put in an excavation unit. Test unit 10 was weird in a good way. And so what we find in test unit 10 is that freshwater mollusks get smaller through time. And the deposits at this unit formed in between 12 and 50 years based on our radiocarbon dates. That's not really a long time. So you have over 1 meter of deposits forming in 12 years. There's evidence of ritual going on here. And we see that the snails are smaller compared to earlier deposits, but they persist through about 4,400 years Cal BP. So in unit 10, we see the later end of the mollusks. In test unit 5, we see sort of that transition between 4,800 and 4,200 Cal BP represented. But in both cases, they're showing us that by 4,200 Cal BP, freshwater snails are gone. It's only marine mollusks. But interestingly, no quahog or oysters. It's just donax and moon snails or shark's eye specifically. So where are the brackish species? They haven't established themselves within the catchment of the Tomoka Basin. One would assume that if those large mollusks, oysters, and hard clam were available, people would have used them. And these folks probably had canoes. And yet within the catchment area of the site, there's no evidence that they were using canoes or watercraft to go collect these things. But they do show up about 3,300 Cal BP when St. John's 1 period groups began occupying and utilizing the site. Geoarchaeology Part 2. My colleague Sean Norman at the Gulf Archaeology Research Institute, who were my partners on this project, because the special category grants for the state of Florida do not grant to institutions outside of Florida. So I use my professional collections and long-running personal and professional relationship to work with the Gulf Archaeology Research Institute through the Gulf Archaeology Research Institute. And my friend and colleague Sean is the geoarchaeologist. So he went out into the Tomoka Basin and up the Tomoka River and began collecting sediment cores. We also collected some cores from the site itself. There's some marshy remnants adjacent to the site that looked like good candidates. And so with PVC tubes in hand and armed with kayaks, they went out into the basin on what looks like a pretty gray and choppy day and collected our sediment cores, which he then analyzed and came up with some pretty interesting results. One of them is that first thing, there has been more sedimentation within the Tomoka River and Basin in the last 100 years than occurred in the previous couple of millennia. But he was able to document the accumulation of peat, both historically and prehistorically, which attests to the fact that the Tomoka Basin has been a marshy environment for a very long time. Regrettably, sedimentation has been so profound that there weren't many locations where he was able to get to really, really old deposits. So while in many cases we got some pretty good data showing environmental transition recently, it was actually the cores closer to the site that were marsh deposits adjacent to the site that were actually pretty informative. And we have evidence of marshy deposits at the site, about 5,200 cal BP, and those look to be freshwater in origin. So we got freshwater marshes forming adjacent to the site, about 5,200 cal BP. Now, the paleoethnobotany essentially confirmed what previous environmental reconstructions of the southeastern coastal plain and Peninsula Florida have already suspected, and that's by about 6,000-ish years ago, modern environmental conditions prevailed. And so at the Tomoka complex, it was expected that you would have a maritime hammock forest adjacent to the marsh edge, characterized by things like hickory, live oak, cabbage palm, red bay, and cedars. All that turned out to be absolutely true. The wood species that were used for fuel and combusted in thermal features like this hearth at the base of the midden in test unit 10, northwest of Mound 5, it provided us with some, some pretty good data regarding wood species. So pine was one of the main fuel woods, followed by oak, palm fronds and branches, with lesser amounts of red bay, hickory, and cedar also represented. Now, this image that you're looking at over here, that is drilled pine. We have, through the paleoethnobotanical analysis, drilled pine wood, 3 different fragments. What is it? Well, one of the interpretations of these very small drilled pine objects is that they're associated as fire starters, for friction fires. That is one of the interpretations of them. Could they have been drilled wood for other purposes? Totally, but they're small fragments, they're burned. Interpreting them, we don't want to go too far out on the interpretive limb and have our interpretations exceed the actual data we have available. But the paleoethnobotanical data showed mainly that the environment was pretty much as it looks today, a maritime hammock forest adjacent to pine uplands. Makes perfect sense. Some of the food-related species, by extension, there was persimmon wood identified, so natural fruits, persimmon. There were possible fragments of saw palmetto berries recovered, and the other one, perhaps medicinal, was the toothache tree, wild lime, sometimes called devil's walking stick. We found evidence for that as well. Oh, and how could I forget? Lots of hickory nuts. And in fact, before I move on, in feature number 2, which is partially underneath the photo board in this feature, we actually had a fragment of charred acorn shell. So folks at the site were consuming mast resources, hickory nuts and acorns, which implies fall seasonality for site occupation. All right, pollen analysis. One of the things that we did in this research was to collect bulk sediment samples from major stratigraphic zones within the site and submit those for a pollen analysis. And the results were some of the most promising. But we did learn, however, that there are some factors that negatively affect pollen preservation. For example, down here at the bottom of test unit 14, those sediments represent largely the dune sands associated with the early Pleistocene ridge. Then there's the Thornhill Lake phase late, very late, shell deposits. And then you have some sandy deposits that are also probably late. And then our later prehistoric St. John's 1 deposits up here. What we learned is that in those dune deposits, the sand is such a hostile environment for the preservation of pollen, basically gets ground up and fragmented and is no longer identifiable. So we really struck out with the sub-midden deposits. So we don't know what the environment would look like before human habitation, but we do know what it looked like during human habitation. and shell deposit and shell deposition at the site. So towards the later end, more recent portion of the Thornhill Lake phase, about 4,400 cal BP, you have in test unit 14, freshwater marsh grass pollen. In fact, you have a mixture of both freshwater and salt tolerant sedges, marsh grasses, but the freshwater sedges are not tolerant of salt water. So if this was a brackish, marshy, saline environment, those plants, like their snails, would have gone extinct, but they're there. So what does that tell us? By 44, at least as late as 4,400 cal BP, freshwater marsh grasses were present in the environments proximate to Tomoka. Now moving down to test unit 17 on the South Ridge, these deposits are older. These are on the order of 5,000 cal BP. And again, these nice, beautiful yellow-brown dune sands, very highly fragmented pollen, didn't preserve, so we really can't say much about that. But from within these Donax deposits dated about 5,000 to 4,800 cal BP, freshwater forbs or sedges are in the pollen assemblage. The salt tolerant species are there too, but when you get up to the St. John's 1 and /2 deposits up here within stratum 1, there are no freshwater marsh grasses, only saline tolerant grasses at the site. So some of our best evidence for the environment surrounding Tomoka being predominantly freshwater come from the snails and the snail predators, as well as the pollen data that we have for the site from the deposits that we sampled. So what can we say about the environment at Tomoka? Well, we're in a Thornhill Lake phase at the site specifically from about 5,050 cal BP up to about 4,200 cal BP. You have freshwater environments and freshwater snails at the site. You have evidence for that. By about 3,300 cal BP, that's the earliest you see St. John. So between for about 1,100 years, a millennium, there's not a lot of activity at the Tomoka site. It's, really only shows up during St. John's 1. And with radiocarbon dates in the vicinity of 45 to 4,200 cal BP, you should expect fiber tempered pottery. There's not a stitch, not a tiny crumb of fiber tempered pottery anywhere at Tomoka. And that's pretty telling. And I have some ideas of what I think that means. So freshwater conditions up to about 4,200 cal BP. There's a period where the site is abandoned for about 1,100 years, and about 3,300 cal BP, all of a sudden, people come back. The occupation is less intense. They're not depositing nearly as much shell as occurred during the Thornhill Lake phase. And as I alluded to earlier, what this is suggesting is that freshwater inputs during the Thornhill Lake phase, which are documented elsewhere based on environmental reconstructions from places like Windover and Salt Springs, the Ocala National Forest. So there is evidence to support increased freshwater inputs because of precipitation locally. And those are probably staving off the intrusion of salt water into the Tomoka Basin for a time, right? And so by 3,300 cal BP, we have evidence for the establishment of brackish ecosystems in the Tomoka Basin. And so you see that reflected in both the zooarchaeological and the invertebrate assemblage, the freshwater, or the oysters and the quahogs. All right, so that's your environmental summary. That's what we learned during stage 2 of the Tomoka archaeology project. But we also found some evidence implicating rituals, and I'm gonna give you a little rundown of that. During the excavation of test unit 10, in our second level, right at the interface of the sandy overlying deposits and the Thornhill Lake phase shell deposits, we found a fragment of a Buzukon vessel. And that fragment of a Buzukon vessel had evidence for thermal attrition or burning on the outside of the vessel, which you can see down there in the bottom right-hand corner in the purple circle. It is gray in color. It's been burned. It's also got the characteristic rectangular fractures that occur. But on the inside of the vessel, there's residues. There's some kind of substance adhering to the interior of the shell. And upon finding that, my mind immediately went to, oh my goodness, we need to document this, save a sediment sample from around it, and we should submit this for a residue analysis, which we did. So during excavation, as we were documenting the stratigraphy and the features at the base of the excavation unit, we found protruding out of the wall of the test unit adjacent to feature 1, the hearth there, the siphonal canal of a right-handed whelk, a knobbed whelk, that also had very clear evidence of being used over fire. It's got charcoal on the exterior surface. It's got a grayed burned surface, and it has another rectangular breakage hole. So when we discovered that, we recovered it, bagged it up with all the entire sediments still on the interior, and also sent that off. So at that point, my spider senses went off, and I thought, wow, we've got a shell vessel overturned adjacent to a thermal feature where we have plenty of charcoal and other materials for radiocarbon dating. It's in a great context. It's in situ. It probably has residues on the interior of it as well. So I devised a plan to send those off because in my mind, my hypothesis was, well, we're on a shell ridge adjacent to a mortuary mound. Maybe what we're seeing here are the remnants of dedicatory and closing rituals associated with mortuary behavior. So let's find out what's in them. Secretly, I was hoping it was going to be the black drink, Ilex vomitoria. So I had a plan. Radiocarbon dates provide us with some pretty good context temporally for the site. And my hypothesis was that these cups were used in the black drink ceremony. Documented ethnohistorically, we know from other residue studies at places like Cahokia that folks were in fact consuming black drink out of both ceramic and shell cups. That's late prehistoric, that's Mississippian culture, but those folks were participating in a ritual and ceremony that we have good documentation also for in Florida. My hope was for archaeological fame and fortune by being the first person to find evidence of black drink going back 4,700 to 4,500 years ago. That'd be pretty incredible, that continuity in ritual practice going from the late archaic up to modern times. So I collected samples of Yaupon holly leaves, sent those to a commercial lab for Fourier transverse infrared spectrometry to look at the different chemical signatures of compounds within the residues of the vessels. And so we compared that to these samples of Ilex vomitoria. The first thing that should be there, if they weren't consuming black drink from those shell cups, caffeine. Caffeine was absent. It's like, well, there go my hopes for fame and fortune. But there are other chemical compounds within Ilex vomitoria that are also absent from the shell cups. All right, hopes dashed. It's not black drink. What is it? Well, as it turns out, there is an aromatic benzene molecule found within the contents of both vessels. Also found in both vessels was fresh water with freshwater sponge fragments. Again, here's more evidence for freshwater environments. There's freshwater sponges. And this is fascinating. Fragmentary human hairs. There were tiny human hairs that showed evidence of mechanical breakage, as though humans were grinding up materials and putting them into these shell cups with fresh water. Now, what could these plants be? Well, as they have aromatic benzene rings, and also there's evidence of waxy substances in the leaves. So we have waxy aromatic leaves. That kind of narrows down the possibilities. And two of the most likely sources of those leaves were red bay and wax myrtle. Very aromatic plants that may have been used in the preparation of freshwater teas, or I'm sorry, fragrant green teas made from aromatic plants. So we have some evidence that folks were brewing these teas in those vessels in association with rituals occurring possibly at Mound 5. And that's pretty interesting. What's even more interesting is that it occurred after the main use of the mounds for mortuary purposes. So they were constructed between and used between 48 and 4,700 cal BP. And here are folks using them 300 years later, perhaps. And I'll come back to what I think that might mean here in a moment. Now, when we come to mound building, I have some hypotheses. I think that the people at Tomoka are migrants from the St. Johns River Valley, at least a segment of the population. They're doing very St. John's Riverine, Mount Taylor, Thornhill Lake phase stuff, such as following the architectural grammar of the St. Johns River Valley. Late archaic mortuary mounds are built on previously constructed shell platforms made some centuries earlier by preceding groups. I found that at Thornhill Lake. There was a construction boom between, make sure I get the dates right, between about 6,300 and about 5,200 cal, or 5,400 cal BP. Then there's a 200-year hiatus, and then folks come back and start adding mounded sand to the shell architecture of the site. Now at Tomoka, we have people doing the same thing, but in a much more abbreviated time frame. They're constructing shell platforms and they're building sand mounds over top of it. But one mound in particular, Mound 2, showed that they weren't just coming there and putting a mound over top of pre-existing shell deposits. They created a shell deposit over which they mounded sand. The shell deposit is restricted spatially to the core of the mound. Through no excavation and no sediment coring, we encounter shell deposits. But in the looter pit in the middle of the mound, there's shell spread all over the slopes of the mound from people having dug into the mound. So they're showing up at the site, they're building sand mounds and following an architectural grammar about 49 to 4,700 years ago. Something else that is particularly striking is the use of indirect heat cooking technology. There's evidence for it in the St. John's, identified at Blue Springs Mid B, at Thornhill Lake, and at the Bluffton site where Ripley Bullen exposed large areas of burned sand and rock. So it looks like folks are using limestone for indirect heat cooking. I surveyed the archaeological literature. The North Midden site, several miles north of Tomoka in Flagler County, had a phase 3 excavation done, big block excavations. It's contemporary with Tomoka. They're radiocarbon date wise, but they're not using indirect stone cooking and they're not using freshwater mollusks. So it appears that there are possibly two different populations occupying and using the coast at about the same time. The other thing that we found were the expanded base microliths. These are small stone tools used for perforating. Very popular in the St. John's, but not very popular anywhere else. Got out Tomoka. And then there's the continued use of riverine foodways like freshwater snails. And so what we find is that the early deposits at the site were used as platforms for shell mounting, as you can see here. I'm becoming cognizant of what time it is, so I'm not going to try to run this on too much longer. I'm sure you all have things to do. Indirect stone boiling is often done in organic containers using hot rocks. We don't have the containers, but we have the rocks. In fact, over here on the right, you see a rather large limestone cobble. And on the left are the heavily fragmented pieces of that same limestone after being heated and quenched repeatedly in liquids. They fragment, they become very small, and eventually they reach small enough size as to no longer be functional. I have thousands of these things, and they're often found in the densest midden deposits. But here's where things get weird. The nearest source of that kind of limestone is Edgewater, further south in Volusia County. The naturally occurring geology in the area of Tomoka is characterized by Anastasia limestone, which is gives us the coquina stone. So folks are traveling distances to get these rocks to cook in organic containers. I'm going to tie all this together in a minute with what I think all this means. The expanded base microliths, well documented in the St. John's, also occurs at Tomoka. I'm not going to go too into detail on those. And then we come to foodways. I'm going to, using optimal foraging theory as a starting point, I'll make it simple for you. You can get a lot more coquina clams, donax, per unit of time invested than you can freshwater snails. Just anecdotally, I was able to collect approximately 5 gallons of donax clams in about 15 minutes using a simple screen and a 5-gallon bucket. They're easily harvested in large numbers. You might also say that for the banded mystery snail, but it is unlikely that the colonies in the Tomoka River were super huge, and they would have represented, based on the yield available per unit of time invested, it would have been smarter to go after donax. What I think is that the freshwater snails collected in the St. John's were a traditional food that was used in ritual contexts. And so effort was made above and beyond what was necessary in order to procure what was socially and culturally appropriate, what one might say is necessary in ritual contexts. All right. So you have all these things converging at the Tomoka complex with precedents in the St. John's River Valley. Mound building, a very specific, regionally specific technology, the consumption of snails, and cooking with rocks. So what does all that mean? Things changed. The world changes. That's how life is. When the folks who started building sand mounds at Tomoka, I believe, migrate from the St. John's River Valley, either they are full-time residents or they are visitors on a regular basis. And not so long ago, I had a conversation with Bob Austin, and he asked me if I thought that the Tomoka site was maybe not a year-round residence, but more of a ritual site. And my answer to that is, yeah, I think that's what it was. I don't think people were living there year-round. I think it was a place where people congregated periodically to carry out various rituals related to mortuary practices, where things like feasting behavior using small schooling fishes and easily collected mollusks were on the menu to support and sustain people while they were living there. Other evidence for that is the fact that there's very little in the way of like domestic artifacts. On a coastal site, you'd expect to find a lot more shell tools. I have like a handful. You'd expect to find a lot more, worn out, discarded bone and stone tools. There's not a lot, especially compared to other sites in the region, like the North Midden and the Crescent Beach Midden, portion of which was pre-ceramic and had like a bunch of shell tools. So I think Tomoka is a site primarily for ritual activities during the Thornhill Lake phase of Mount Taylor. Now, around 4,700 years ago, they stopped building sand mounds. So what were they doing? Their monumental architecture shifted. They became more oriented towards the construction of a shell ring at the north end of the site. Now, that shell ring begins about the end of mortuary mound construction at the site and persists well into the ring building culture we associate with Orange period. This is test unit 12. There is a really weird sand-filled trench excavated prehistorically into the shell deposits of the ring. What it was for, I don't know, but I will share this anecdote with you. I was really afraid we were going to find a burial. We didn't. So happy day with that. But we did have a shell deposit that began around 4,800 cal BP. And then the ending of the deposit is about 4,200 cal BP. And we have two other dates associated with the shell ring in Mound 1 that are between 45 and 4,200 cal BP. Now, what's interesting about this is that fiber tempered pottery already exists. It's already being manufactured in the St. Johns River Valley and elsewhere on the Atlantic coast of both Florida and Georgia. So why is there no fiber tempered pottery at a late archaic shell ring at Tomoka? Tradition. I think that the folks at Tomoka maintained a non-pottery making way of life where they were still using hot rocks and organic containers to carry out feasting associated with ritual activities. We see activities associated with the ridge adjacent to Mound 5, 47 to 4,500 cal BP. They're brewing teas in shell cups over a short period of time. At the shell ring and adjacent to the shell ring, there are people there depositing shell with freshwater mollusks also included as late as 4,200 cal BP. And then after 4,200, they're done. There's no more ring construction. There's no more shell deposition. And apparently so far as we have thus far found from our work out there, no occupation of the site until later during the St. John's 1 period. Now, this is where things get kind of interesting and we can learn from the previous excavations. Bruce Piatek's excavations of Mound 6 back in 89, the field work that was done. No, 92. 92, the field work was done and the results were published by 94. There were intrusive burials into Mound 6. Later peoples during the St. John's 1 period were reusing the Thornhill Lake phase mounds for burials as well as constructing their own. Mound 2 was excavated by James Griffin in 1946 when he became, I think he's an archaeologist working for the Park Service. He excavated in Mound 2 and found intrusive burials lacking pottery. So it may be that folks were no longer building sand mortuary mounds, but they were engaged in ritual activities that involved the production and consumption of food in a shell ring environment, and then perhaps interring bodies in previously constructed mounds. And so, that is what I think was going on. While their neighbors to the north and over to the west of the St. Johns River Valley were constructing shell works like shell rings and shell ridges, making fiber tempered pottery and engaging in integrative ritual acts, bringing people together from diverse communities geographically and culturally. The folks at Tomoka seemed like they were doing the same thing, but they were making the pots. And that in itself is fascinating, but not unknown. Ken Sassaman's work at Stallings Island showed that the folks at Stallings Island were making fiber tempered pottery and cooking with hot rocks in the pots. Neighbors on the coast were cooking with pots directly over fire. Now, the reason why that's interesting is because the folks that Stallings Island residents were interacting with and marrying were the folks making soapstone cooking slabs and banner stones, and they didn't make pottery. They were contemporary, they were next door neighbors, they intermarried, but Mill Branch culture did not make pots. And I think something similar may have been occurring at Tomoka, where the folks at Tomoka, for social reasons, opted out of pottery making in order to maintain what we might call tradition and continuity with the past. There's a picture of the shell ring. We need much better LiDAR data to show these features in greater detail, but maybe one day. So in sum, I think Tomoka, at least a portion of the population were migrants from the St. John's based on similarities in artifacts and various technological processes. The local environment terrestrially was the same. Tomoka was a freshwater river ecosystem up until about 4,200 cal BP. And after 3,200 cal BP, we see really good evidence for that when people began depositing freshwater mollusk at the site. but the mortuary mound construction itself ends about 4,700 cal BP, when it appears that activities related to food consumption and depositing of shell and ring form begins occurring at the site. What does the future hold? I want to go test the shell ring some more. I have questions. I need more data from the shell ring, so I'll probably do some additional work there. Stage 3 of the Tomoka project is going to require lots of money, buckets of money. We're talking NSF research grant, multi-year, hundreds of thousands of dollar grant, because I need to open up block excavations and do detailed studies of subsistence and seasonality. And the block excavations are going to be labor intensive, require a lot of work in order to do spatial analysis of the occupation areas, not the mounds themselves, but the areas where people were actually living during the various activities occurring at the site. And hopefully, maybe one day, I'll be able to write a book about all of this late archaic mound construction, mortuary ceremonialism, ritual, migration, and all those fun things, and publish a book on it. That's long-term goals. I have other things to work on for now, but that is the long-term aim of all this research. There's a list of acknowledgements. Thank you to Dawn and to Chris for reaching out to me and making this possible. I really appreciate it. I love talking about Tomoka and all things related to late archaic mounds. And I've gone like way over, like it's like 22 minutes over what I should have done. I guess that's it for me. I'm going to stop sharing now.
Yeah, if anyone has any questions, you can unmute yourself and just ask John, and we go from there. I don't hear any questions, John. I think you did such a good job that they don't have any.
I have a question.
Yes.
I have a question. Just a minute. I have to switch glasses for the computer.
I know what you mean.
My question is about current everyday threats that you might have noticed in terms of sea level rise, flooding, and erosion.
Right. So I do a lot of work with the good folks at FPAN, with Sarah and Emily Jane and Emma Dietrich. And this December, we are going to do some LiDAR drone flights over Tomoka so that we can map the shoreline as it exists today and site features. I think long-term sea level rise is going to be a major threat to the site. And because the site is not very far above sea level, you know, if a hurricane just happens to come up the coast just right, it could push a storm surge right up the Tomoka River, up Strickland Creek, and begin undercutting Mound 6 and Mound 2. Those are at the greatest risk currently based on their elevation. So long-term, that is one of the big risks. And also one of the reasons why, I guess it was last summer, we managed to get Tomoka listed on the National Register of Historic Places so that it could receive extra consideration and mitigation if those things occur, being an R-listed site.
Okay. I have a follow-up. While I was listening to you, I suddenly had a memory from who knows how many years ago when I was contacted by somebody for some, I can't pull the details together, but it was about wanting some rangers down there wanting to know what to do about a site that was eroding that they were aware of. Mm-hmm. And I sort of think that I just referred them to the document that the DHR had produced before that time. And at the time, in my mind, it was maybe associated with boat wakes, but I'm not sure.
Are you thinking about the No Kuroko village at Tomoka Point?
Don't know.
That site, they've done a lot of I'm not sure if you call it remediation, but they brought in a lot of riprap, stone, concrete, and just protected the eroding Tomoka Point from tidal surge, from boat wakes, from normal wave action. And I think that was precipitated in 2013 or 14 when
This
burial.
would have been way back, way before that.
Oh, okay.
I just can't remember.
I mean, they have taken steps since then, but I'm not sure who the park manager would have been based on how far back it was, but the current park manager, Phil, is very proactive in protecting and managing his resources. In fact, I went out in, what was it? Was it May? It was back in May with FPAN and the Heritage Monitor Scouts to go and monitor sites within Tomoka State Park, including the Mound and Midden Complex. So they're doing a much better job now, I think, of monitoring the sites with the assistance of HMS and FPAN. And Phil's a really good steward of the environment and the cultural resource in the site. Like he's been a dream to work with, just like so supportive. I'm very appreciative for that.
Okay, thank you.
Sure thing.
Did you say Tony?
Yeah.
You mentioned hickory nuts on the site.
Yes.
Could you talk about whether that was a significant part of their diet or what that represented?
That's actually a good question. In terms of how significant it was, I don't think we have sampled quite enough of the site to be able to say that for sure. I mean, we get hickory nutshell pretty commonly, but as here's the thing, not all hickory nutshells get preserved. And in order to be able to assess how significant it was, you'd have to have good preservation. And so chances are a goodly amount of hickory nutshell never made it into a fire and got carbonized. It decomposed and we'll never have any record of it. And so what we're faced with is a limited sample size, which might suggest that it wasn't as important as it could have been. And we know from ethnohistoric accounts that hickory nuts, walnuts, chestnuts in the eastern US was a food boom for people in the fall months and were used for overwintering. Now, Florida is a little different. The climate's a little more friendly for humans and foraging, but hickory nuts would have been a seasonally abundant food resource. And the evidence that I have for the site points to at least 4,500 cal BP. People were there during the fall. We have nutshell acorns in archaeological features. And I had one of my students do a size analysis of a Donax shell. It has an annual life cycle. And with some really good advice from Mike Russo, he said, don't sample the midden deposits, only use feature deposits. Okay. It looks like the Donax were being also collected in the fall. So it appears that folks were heading there in the fall for take advantage of Donax shells pretty close to the apex of their maximum growth, and hickory nuts, which would have been just fallen from the trees and would have been easily collected and used. So I think it was important, but there was a number of things working against us that we're just not going to know. And that's one of the things that Lee Newsom, who was the archaeobotanist for the work, said that in a place like Salt Springs, the Ocala National Forest, where the hickory nuts were being deposited in a watery environment, they preserve better. Whereas if you have to rely on them being burned, you're rolling the dice. Maybe they'll get burned, maybe they won't.
Mm-hmm.
So I think hickory nut was probably underrepresented archaeologically.
Thank you.
Mm-hmm.
John, I remember when our group walked out there, and that was the time that you found the nails out there from the
right. I didn't even mention the historic component.
On the road, we did find a small piece of pottery. I don't know if Philip ever mentioned that to you or not.
Actually, yeah, he showed it to me. It was St. John's Plain.
Right. Yeah, there was no marking.
Way back to it.
Great information. Thank you very much.
Sure thing.
Anybody else? Well, I want to thank you, John. It was a very interesting presentation. I'm sure everyone enjoyed it. I know a few people came in late, but just want to remind you that we are recording it. It will be on YouTube probably tomorrow, and you can get the link either from the SAAA website or the Facebook. Let me go on to the name that artifact. I'm sure we're all anxious to figure out what this thing is. Catherine, are you with us now?
Yes, I am.
Okay.
Hello.
Can I
That's it.
guess?
Yeah, please.
Oh, Susie, you can't guess again. This is like 3 in a row now. Go ahead. What is it?
I think it's a piece of furniture, like you'd see on Antiques Roadshow. They call it a maybe a bat wing, part of a
No.
hinge on the furniture.
No.
All
no
right.
good. No good.
It's a good guess, though.
Anyone else? I thought this was an easy one. I thought you'd get that one. No guesses?
Is it the tip of like a belt or some sort of clothing adornment?
It's a good guess, too. You're getting warmer.
Yeah, it's a little closer.
It's very small.
Dawn,
It is.
I think it looks like a corner protector from a giant ledger book.
Ah,
And that's exactly what it is. Yep, it's a book corner. This one is made of brass, and it was actually found on school number 2 as one of the early African-American schools in Lincolnville. It was in one of the trash deposits, so it was probably from a book. You still see them from time to time on like Bibles, still have them, like really decorative, nice family heirloom books. And the hardware of book corners has been around for hundreds and hundreds and hundreds of years. It dates back to when books were handmade and expensive commodities with hand-painted pages and clasps and hinges and things that needed to help kind of keep those books intact and together. So this one is from the early 20th century, but they've been along for a lot longer than that. So that was a really good guess.
Very interesting.
Thank you, Don.
okay, super. Let me get rid of that screen for a second. I'm trying to get a chat out to you folks. I know we talked about people who may be interested in helping with the FAS conference. Let's see if we can get that out. I don't know why it's not going out.
That's going to be in 2023.
2023. Yeah. Let me give you my email address. It's pretty easy. It's D and it's W and it's Roberts. Only put a Z instead of an S. It's DWROBERTZ@gmail.com. So if you are interested and can help us out, we would appreciate it. Just give me a fast email and we'll be back in touch with you. We do have time. The conference is probably going to be in May of 2023. And again, we need all the help we can come up with.
I can
All right.
promise I'm coming to that one.
Okay, in closing, I just want to mention one more time that the next meeting will be the Christmas party at the Lambia House on the 14th of December. 5:30, we'll get a memo out. And the following meeting will be on January 4th, and hopefully it's going to be a live meeting at Flagler College. And we'll look forward to seeing all of you both at the Christmas party and at our live meeting. And with that, I thank you very much, and I'll end the meeting.
Thanks for the opportunity. Appreciate it.
Okay,
Thank
take care
you.
now, everybody.
Bye-bye.